With the pandemic came the rise of the mobile worker. Here we are almost 4 years later after the start of the pandemic, and pretty much the world is still largely remote. People love working from remote, and they rely on the remote access solutions. But it's been quite a while now, and we have to ask ourselves at this point, are we doing remote access the best way that we can? We're going to examine that.
Welcome to Tech Topics, brought to you by CyberVenger. We help keep small businesses stay protected and compliant with cutting-edge cybersecurity and IT solutions.
Okay, so we're mostly used to remote access through something called a VPN, Virtual Private Network. A virtual private network, on this little diagram sitting here, looks like you've got somebody either at home or remote or maybe from another office, and they're on a connection that's public, where anybody could be spying on the traffic going across. We need to make sure that that traffic is encrypted so that anybody observing the traffic gets to them what looks like scrambled data that cannot be descrambled without some kind of special private key or something to that effect. So users will have software loaded on their workstation or their mobile device, and they'll engage that VPN. Very commonly, you'll have an IPsec client that connects to a Sonic wall or a Cisco ASA or some of the other ones. There are other options to remote control through like a third-party cloud provider, something like Remote PC or TeamViewer or one of those as well. We're not really going to discuss that so much. The approach that we're going to talk about today is going to be dealing with the VPN solution. So there's two types of VPNs. There is IPsec, and then there is SSL VPN. And both SonicWall has both of those. I think Cisco does as well, and many other providers like Fortinet or WatchGuard and all that. But the thing is, when you're connecting up to your firewall for VPN, that firewall has to consume a lot of its CPU to decrypt and encrypt traffic going across. And there's a lot of solutions out there, but they're all kind of expensive. But one of the things that I came up with that I found is an open source platform. It's actually free that you could load an environment. I'm assuming, if I say free, that's if you actually have any room left in your virtualization infrastructure. So, and hardly anything will do. I mean, you could, 2 gigs of RAM, I think you could pull it off. You probably want more like 4 or 8 if you got any substantial amount of users. But like 8 gigs of RAM, let's say, 32 gigs of hard drive space, 1 or 2 cores, and you could load an Ubuntu Linux guest on your environment. And that would be enough to run what's called OpenVPN. Now there's a paid version and a community version. The paid version is a little pricier. Obviously, you pay for it, but it's a lot smoother. You get support, and a lot of environments you're going to need that for compliance, for just to have the support around, especially if you're a larger company. But if you're a small shop, you may want to check out and take a look at the community version, because that works pretty darn well. And that's what we're going to demo today. I'm going to walk you through installing the VPN and the certificate authority services that it depends on onto an existing Ubuntu box. And I'm going to skim over some of the requisite setups, because I think most people who know Ubuntu and Linux can do that. And maybe I'll do another video on how to use Ubuntu. I don't know. Seems like a ton of videos on how to do baseline installation for that. So we're going to get started here. Look down here. Okay, so first things first. This is a really good website to use for instructions, but it's not perfect. It's missing some things that we're going to go over, and a couple of things are wrong that we'll talk about. But for the most part, it's not bad. So we're going to start off here. We are currently connected to our Ubuntu box over SSH. Again, there's some setup there, but most people can handle that outside of this video. And so we're going to copy and paste the first command, and we're going to install the OpenVPN and the EasyRSA. I put in my lab password here. And it's cooking along. So the EasyRSA is actually kind of a nice tool. You can use that to generate and sign certificates for, other stuff. It doesn't have to just be for this. Although, really for the VPN, I like to keep them separated. All right, so that's installed. And we are going to now set up the EasyRSA infrastructure. Here it comes next. Jump ahead here. First thing we're going to do is we're going to tell it where the directory is that EasyRSA should live, where all its configuration files. We can kind of sort of put that anywhere. I recommend that we put that right in the OpenVPN directory, because that's what we're going to use it for, and that's easy to find. So here we are. We're in that directory, and we are just going to make that go. And there we go. It's what they have here. I liked it. Okay, so now that we have that directory created, now it's time to go in there. See, it doesn't actually tell you to change that directory, but you should change that directory. Yeah, here we go. Okay, change the new directory. So we're going to do that. VPN easy-rsa. Okay, permission denied. Since all we're doing is like admin commands, it's probably not a bad idea to do sudo-s, and that way we never have to worry about that command again for the rest of this. Easy RSA. There we go. There's our stuff. And we're going to want to run easy RSA init-pki. This is just set up the basic infrastructure for this. If you look, it's pretty. If you look what's in there right now, there's really just easy RSA and a couple other configs. So this will build our PKI folder there. That's there now. And then we're going to want to build the CA itself. RSA build CA. And it's going to want a key phrase. Now, this key phrase, you will need to know this every time you generate a certificate. All right, so don't forget what this is. I'm just going to cheat and use my same password I use for everything else for my lab. Because this is just a lab. It's not production. In production, you probably want something unique and special. The name here could be whatever. Okay. Next, we're going to create the Diffie-Hellman. No, next we create that. Yeah, that's later. Next, we're going to create the certificate that our server is going to use, and we're going to name our server, not my server, but we're going to call it OpenVPN. Paste that puppy in there. OpenVPN. Yep. There we go. Okay, so now we have that. Next, we're going to need our Diffie-Hellman settings. And it's going to create a .pem file for us when we're done. I'm going to launch that. This actually takes a little while, so I'm going to cut the video here and jump in when this is done. Okay, that finally finished. Probably about good 2 minutes for that to run. Now we're going to attempt to assign a server certificate here for ourselves. Kind of the first thing our CA is going to create. We're going to request, sign request, and servers, telling it that it's to be a server certificate. And then we're going to make the name, and we're going to make the name OpenVPN. Oops, OpenVPN. There we go. Yes, go ahead and do it. And now it wants that password. Remember I told you, don't lose that password? This is where you need it. Okay. That one's done. And now we're going to go. What we want to do is we have our request here. It's been signed. Now we have a certificate. Now we have our PEM certificate, our CA certificate, our server certificate and key. And normally it's saying here you should copy this to your etc OpenVPN, which actually, I agree with that. We're going to get that done because it's got to be able to find it. Because these certificates, OpenVPN needs to run. It can't run without them. So we are going to copy this whole darn line. And let's see if that works straight away, which I think it does, actually. Nope. Hang on. Yeah. CD, PKI. What is it complaining about? Oh, I didn't change the names because I'm silly. Yes, that's what we got here. OpenVPN. So make sure you change your name to match whatever you used. All right, copied all the files there. So now The next step here is to create the client certificates, but I think that's jumping ahead. There's other things we still need to do. I'm going to save that for later. We're going to do a second part of this video to go over the client side up and how to connect. There's actually quite a configuration to do on the client. Once you get it down, when you create your initial configuration file, you can import it to other things. That makes it easier. But the initial is a little tricky. So we're going to skip this for now. And we'll move on to the last certificate that we're going to do. And that is we're going to create the TA. Here we go. These settings in the server. So back to here. We are going to create our TA file. Now, what the TA file is, it's going to be the same key everybody gets. It's just a way of stopping DOS attacks. If you run this, you can... Does it work? Yeah, it worked. And there we are. There's our TA. And easy errors. That's not what we want to do. We want to move this. Move TA.key. And we want to move it back one. There we go. Okay. Yeah, TA file, if you're using that, it allows an initial connection that's light and proves that you're not a complete stranger, and then you can go on and try and do more. Otherwise, it lets anybody bang away at the authentication process. I guess you can... I don't remember what the exploit exactly does, or how you were able to do it, but it ends up overloading it, and it collapses, and then that's a DOS attack. Can't break in, can't steal data, nothing like that. But still, I mean, a DOS attack is not fun either. So I'm going to assume that we're going to use the TA file as well when we configure this. Now, the next thing we're going to do is we are going to go and we are going to make sure that once we're connected over VPN, we're able to route. Because when you're VPNing in, you're going to get a different IP address than you do on the general network. We'll talk about that momentarily. I already set up. Now, Ubuntu does not come with Vim. I install it because I like it. You could use Nano. I don't. Personal preference. sysctl.conf. And then there we are. I already did this earlier. So you just basically got to find it and uncomment it. It was commented out by default. And that just allows routing. And I could reload here, but I don't need to in my case because I already did that. Now, we have that set up. But I also note, so IPAA, and you can see all the network adapters. On this particular setup, what I have here is I have my static IP address on one network, and then I have my static IP address on the other network here. I have two network adapters. If you were doing this behind a firewall and connecting to it from outside, you could get away with one network adapter, and it works just fine. It has a different subnet, and then... Well, in fact, I'll show you that. That is our very next thing to do here is work with our config. So if we backtrack a little bit in this document and go back to here, sample configuration. This is a little bit wrong. It talks about the server.conf.gz file. That's not there anymore. They don't do that anymore. So I think that's slightly out of date. The config file is there. It's just not in a GZ file. So if we go and we change directory to user share doc OpenVPN examples, there we go. This directory cd sample config files. This directory so far is all correct. Wait, no. Sample-config. Oh, flies. Yes, no, flies. We don't want flies. We want files. All right, there we go. But if you notice, no GZ file. So all we got to do is copy server.conf and to etc OpenVPN. So that's slightly different than what the documentation says. That's why I'm calling it out. I had to find that out the hard way. Now, the server config file... It's in the same directory as all of our certs and all that. That's important to keep in mind. And that is what really runs this whole thing. So vim server.conf. We got to edit it. It's a good starting point, but it's not everything you need. So first things first, I'll show what the top looks like, and we'll just walk through what we want to change. A lot of it you don't need to. Some of it's optional, and some of it definitely want to. So the first things first, We got a lot of commented stuff out. Can't read half of it. But your ports 1140 and 1194 leave the default. UDP, yep, leave the default. Dev ton, leave the default. All that stuff. So we have our comments. So that's commented out. Now here we have our certificates. We absolutely have to make sure we get these right. So I'm going to delete that and open VPN and open VPN. So now these certificates here, that's a certificate and that's its private key. This is what the server uses to authenticate itself to clients. And the CA has to be shown, the CRT file, no, it's not the private key. But the CRT file is there so that so it's showing here, this is I am, and this is who signed my stuff. That's the whole certificate chain, not just the individual file. Here's our Diffie-Hellman file that we created. This is named wrong. We got to get rid of that. Yeah, we want to get that there. Okay, so this is our first real decision thing to look at. 10.8.0.0. This is the subnet that your SSL VPN clients are going to get when they connect. It's a DHCP range. That's where they go. You can define how big it is by changing a subnet mask, that sort of thing. The first address by default will be the gateway. Keep that in mind that your clients have to use. We'll talk about that in a second. So, and this is just a file that keeps track of the active leases. You probably don't want to do bridging. That's not the config I used anyway, so leave that commented out. Okay, push. This is an important one. This is configuration that your end client gets. In this case, I have this network behind the firewall, so I'm going to push a route to get here. Otherwise, it will not be able to route this network. It'll get 10.8.0.0 and have no idea how to get to anything behind that. So this is how you do that. And you can isolate certain networks. So if you have a network and your VPN appliance, you only want certain things accessible, you can add that here. It wouldn't have a route otherwise. Not foolproof because you can always do a static route. There are other things you can push, like you could push, you could tunnel all. That would be where you're to do tunneling all. You could push DNS options if you want. That's actually probably another one that you may want to do. And then most of these defaults are pretty good. Here, this is another one this is something you want to change. So TLS-auth. This is that TA key we saw earlier we're trying to set up. TLS-auth does not work as well as TLS crypt. Yeah, crypt. You want to change that to crypt. That's less sensitive to direction and things. Auth, I couldn't actually get auth to work. And crypt encrypts more of the stuff anyway. It encrypts the entire header instead of only part of it. So I'm not sure why I wouldn't want to use that. All this is pretty much, you can maximize, say what the max clients are in case you, for some reason, think you got too many. All the rest of the stuff is good as default. This is the last thing you really want to do here, I think, is you definitely want to turn additional logging on. You want to be able to see what's going on with your VPN. Verb, this defines how advanced the logging is. The higher the number, the more information. Of course, the more load in the system, the more you're going to choke out your logs. So 3 is the default, and that's pretty good most of the time. And that's pretty much it. I'm going to exit out of there. So the VPN server itself is now basically configured. One last thing we got to do, we want to configure the firewall under Ubuntu. Ubuntu comes with UFW as the firewall, so we want to make sure we allow 1194 UDP. So if you look down here, all we got to do is sudo -s. Okay, so UFW allow 1194 and then UDP. It's updated, and then UFW enable, make sure it turns on. Yep, there we go. That should be all we have to do to enable the firewall. Okay, so that should be pretty much all of the configuration on the server side. And again, the process is you're going to install a client on your client software. You're going to copy down the files that they're going to need from the server. Oh, that's the last piece we're going to need to do. So if you look at these files here, you're going to need to create client files, and you're going to need to have them access to the CACRT and the TA key. Now, you're going to use a different file for each client that you have connecting. That way, you can you can revoke a specific certificate and get rid of a user that's been fired or quit or laptop stolen or anything like that. Because otherwise, anybody who has the certificate can connect right on in to that network. Now, they may not be able to go anywhere else after that. In an environment like this, you would probably want that to just be the first connection state, and then the other half of the connection be controlled by password. That way you can have something you have, something you know, two-factor, and then satisfy all compliance needs. For folks that don't have compliance needs, honestly, just having the certificate and connecting out is pretty good. The odds of some random person on the internet breaking into that are next to none. They would have to really get a hold of your certificate, recognize that it's valuable, and know where to apply it to get in. So for low security clients, I think it's acceptable. For higher stuff, if anything, using like NIST 800 or 171, this would not by itself be acceptable. You would also have some kind of password mechanism like it described, where you remote in with the certificate, and then you're in a limbo area. We can't really do anything like a DMZ. We have no access except to do the next hop, or maybe like you would have an RDP gateway or something similar like that. So, but let's go ahead and jump back to the client configs now, and we're going to do that here. We're just going to call it my client 1. Go ahead and stick with the default. And this could be like, Bob from accounting. In fact, why don't we name it Bob from accounting? Just so Bob Jones. That's it. Bob Jones. That's our one employee, Bob Jones. Oops. Yeah. I'll have to go into easy RSA when I do that. There we go. Bob Jones. Bob Jones is done. That's just the request. You could make that request at the client and copy your REQ file up, but that's a lot of work. It's just to copy stuff back anyway. You might as well just go ahead and do the typical thing. Bob Jones. And now we're going to sign the request, and it's going to ask us for a password. There it is. Okay. It's going to ask us, it's a yes, and then it's going to ask for a password. Okay. Now that's done. So now what we've got is we got a lot of files that need to get downloaded. How are we going to download them? Well, first we're going to move into a directory we can reach them to. If you use a tool like WinSCP, the first thing it's going to do, it's going to connect you as that user at the home directory. So let's stick all the files we need there, shall we? So if we go back to... All right, there's our CP. Now we're in OpenVPN directory. So we're going to copy ca.crt because we need that file. dh.pem and then ta.key, and we're going to move it to home, and our user is just user because I was unimaginative. And that's those 3 files. No, I don't even need the DHPM. I'm sorry. Hang on. User dh.pem. We don't need that one. I was wrong. Okay. So we need CA, we need TA. And that's going to go to everybody. Exact same copy all the time. Now, for Bob specifically, we're going to have to move Bob's stuff. So what we're going to do is we're going to copy. In fact, let's go in here. PKI. CD easy RSA. And then PKI. And then we're going to go to issued. And there's all our certificates that we've been issued in CRT form without the key, the private key. We'll start with that. So Bob Jones.crt. Stick that in home user. All right. And now we got to go get the private key. And that is in a folder called private. Not particularly unsurprising there. And then we're going to copy Bob Jones.key. Stick them home. There we go. Now, if we go home, when you log into this to WinSCP to the server, you're going to see these files, but you still won't be able to read them. So I'm going to do change mod 644 to everything, and boom. Now, if I do ls-l, we'll see that everybody's got read writes to the files. And I probably shouldn't have done that to my home directory. I just realized that. Well, whatever. It's a lab server. But you can do, just the files so that you can see them. And then next video, we're going to show you how to download them and apply them. And that is all we have on the server itself. So that's part 1. And stay tuned for the next video for part 2. If I did this right, I won't have to show anything in part 2 about going back to the server. If I forgot something, then in part 2, I will in fact go back and show you. So you may want to watch both parts before you consider the server completed, regardless. All right, thanks a lot for watching. We'll see you in the next video.
Thanks for watching. We hope this video has provided valuable information to you. Be sure to share this video with other small business owners to spread the word about the importance of cybersecurity. As always, don't forget to like and subscribe for more videos like this. If you want more information about cybersecurity, visit us at www.cyberventure.com.